Hello, welcome back to another episode of Math with Laws. You're watching Precalculus Season 2, Episode 29. We're continuing our investigation of trigonometry, and now we're going to consider the addition, subtraction, tangent identities. So, we've learned previously that cosine of alpha plus or minus beta is equal to cosine alpha cosine beta minus plus sine alpha sine beta. And we learned that sine of alpha plus or minus beta is equal to sine alpha cosine beta plus or minus sine beta cosine alpha. Alright, let's see here. Double checking. And I'm good. I like that. Alright. So, what we're going to consider now is question of tangent alpha plus or minus beta. And in fact, before we do that, we're going to consider the case 1, the addition. So we can note immediately that tangent x is equal to sine x over cosine x. Well, that means then this is the same thing as sine of alpha plus beta divided by cosine of alpha plus beta. And then we can expand this out. So sine of alpha plus beta, so that's sine alpha cosine beta plus cosine alpha sine beta divided by cosine alpha cosine beta minus sine alpha sine beta. Alright, that looks nice. Now, what we want to think about is that we want to turn this somehow into a statement about tangents. So, if we think about what we have here, right? We got a sine times a cosine term here, right? Sine times cosine. We have a sine times a cosine. And we got sines over here. What we want to do is change all those sines into a sine divided by a cosine of the same variable so that we get sine divided by cosine, which is tangent. So what we are going to do to accomplish this is we're going to multiply it by a clever choice of 1. And this is, our choice of 1 is going to be cosine alpha cosine beta. So we're going to multiply the numerator and denominator by 1 over cosine alpha cosine beta. Alright. So let the algebra fun begin. So what we have going on then is this quantity here and this quantity here both have to be multiplied by this entire fraction. So this is going to be distributed accordingly, and similar situation on the bottom. So when we consider sine alpha cosine beta in the numerator, it's being divided by cosine alpha cosine beta. So we have sine alpha cosine beta divided by cosine alpha cosine beta, and we have plus cosine alpha sine beta divided by cosine alpha cosine beta. That entire quantity. Now we're going to do the distributions on the denominator. So we get cosine alpha cosine beta divided by cosine alpha cosine beta, and minus sine alpha sine beta divided by cosine alpha cosine beta. Alright, now let's get out our red pen and note that these die, because cosines of the same thing. These die, and these die. So I just want to note that right here, even though all the cosines here died in this term, the cosine alpha, cosine beta over cosine alpha, cosine beta, that's going to leave us with a 1, not 0. I've seen some students make that mistake before, so just keep in mind a 1 survives. Okay? And it's just because you have the same quantity divide by itself, so you should have the 1. So when we look at this now, let's just rewrite it. So we have sine alpha cosine alpha plus sine beta over cosine beta divided by 1 minus, now I'm going to write it this way, sine alpha cosine alpha sine beta over cosine beta. Alright, and that's of course being multiplied. So each of these quantities now is a sine divided by cosine, and they have the same variable. So this is going to be a tangent alpha, this is going to be a tangent alpha, and this quantity is going to be a tangent beta and a tangent beta. Alright, so this then becomes tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So that is what tangent of alpha plus beta is equal to. Now we can do something similar as we did in the previous two videos if we want to figure out what tangent of alpha minus beta is. So if we say that tangent alpha plus m is equal to tangent alpha plus tangent m over 1 minus tangent alpha tangent m, then if we say that m is equal to negative beta, then we have tangent of alpha minus beta is equal to tangent of alpha plus tangent of negative beta divided by 1 minus tangent alpha tangent of negative beta. Now if we recall the even odd properties for tangent, tangent is a odd function, which means that tangent of negative x is the same thing as tangent of x. Therefore, this is going to simplify to tangent alpha minus tangent beta over 1 minus or 1 plus tangent alpha tangent beta. So we get the plus sign in the denominator because this negative here moves out, so you get a double negative because you have negative and then negative that quantity. Alright, so to summarize now our results, tangent of alpha plus beta is equal to tangent alpha plus or minus tangent beta divided by 1 minus or minus plus tangent alpha tangent beta. So the thing to note, I forgot my negative sign there. Here we go. The thing to note is when you have a plus sign here, you want to use the plus and the minus and leave everything else the same. And when you have the tangent of two angles being subtracted from each other, and then you would use the signs I just highlighted in blue. Okay? So that's what that notation is getting at. It's just a nice, more succinct way of expressing these identities without having to write all that 2 times. And with that, we have discovered our addition subtraction identities for tangent. Alright, if you've enjoyed this video, please subscribe, consider supporting us on Patreon. Thank you for joining our math party, and I will see you next time.